Okay, so for the second common force is called the tension. We're going to use a symbol capital T for it. The tension comes with the string. So the tension is the force that a string acts on an object. And use that as a hint. It means that if there is a string, then there is a tension. If there is no string, then of course there is no tension. So to draw a tension, you always draw the tension along the string. Away from object. Okay, always away from object. Okay, so for example, once again, let's say that I have a box. I mean, obviously there is going to be the weight of the box, but let's say that I don't care about that for now. And let's say there is a string attached to it. So maybe it is quite a thick string, but sometimes they could draw it as a thin string as well. Okay. So now, a box attached by a string. You don't need to think too much. We draw it. We start drawing the tension at the point where the string is attached to the box. Draw along the string. In this case, the string is flat, it's horizontal. So we draw it horizontally and away from object, so it means to the right. So label it capital T. Okay, so that is the tension. Now, so this tension is the force that the string is pulling the box to the right. Now, I said that the tension is always acted away from object. Because imagine in this case, let's say I'm like standing here and I hold onto the string. Of course, what happened is I can only use a string to pull the box to the right. I would not be able to use a string to, let's say, pushes the box to the left. It's just impossible, right? So that's why the tension in the string will always be away from object. But now, let's look on the other side of the string, like right here. On the other side of the string, I say it could be my hand, like literally it's just my hand holding on to it and pulling it. Okay, please excuse my attempt at drawing the hand, but let's say that's my hand pulling it. Okay, try to pull this to the right. So the question could be, then what is the direction of the tension that is acting on my hand? Because don't forget, my hand is like an object, the object being attached with the string. So we're going to use the same law as before. So the string acts on my hand. It's act along the string away from object. So in this case, to the left. So even though I'm pulling the string to the right, but the string is pulling my hand back to the left. Just imagine, it's like if you really try to pull it, and maybe let's say the box is like really heavy box. When you try to pull it, like the string is trying to pull your hand backward. That's the tension. That's a tension that acts on your hand. And for example, if you pull really hard, it's gonna make your hand hurts because, well, the tension will be pulling your hand really hard, and that makes it hurt. But that's the key. It means that no matter where the string attached, okay, like you can see this string is attached at both ends, the left and the right end. No matter where the string attached to the object, there is a force. There is always a tension, and the string always acts away from object. Secondly, these two forces, the magnitude of them will be equal as well. Okay, very important here. Tensions at any 2 points along the same string are equal in magnitude. So it means that if I know how much is the value of the tension here, I would know the amount of tension here right away. Okay? Now, and this probably is a good time to introduce the unit. The unit of force, every single force has a unit of Newton. So when you push the door or when you pull the door, it's just like how many newtons that you push or pull it. So coming back to the weight, okay, the weight is actually a force, so your weight is actually given in Newton. So for example, when someone asks me how much is my weight, I should not answer in kilogram, okay? If I answer, let's say 70 kilogram, that is actually the mass, not the weight. The weight should be 70 times with 9.81. So whatever that number is in Newton, that is truly my weight. Same thing with the tension. So the tension is given in Newton as well. So if I know that the tension here is, let's say 5 Newton, then the tension here would also be 5 Newton as well. Now, notice that I only mentioned about their magnitude being equal. I did not say anything about the direction. In this case, yes, the direction of these two are opposite to one another, but it's not always. Okay? It's not really necessarily. For example, sometime you might see a question like this. Like maybe you have like a random box here, you have a string hanging it, and then it passed over a pulley, and then you have another boxes here. Then what do is, there is going to be a tension here. See, every single time a string attached to a box, draw a tension away from object, in this case upward. The other end of the string, also there is another tension right there. Now, of course, these two tensions would be equal in magnitude, but you see the direction is the same. Okay? So there is no set rules of what is the relationship of these two tensions, but the magnitude wise would be the same. Okay? But in terms of direction, it's always acting along the string away from object.